Hi, students, how are you? This is our lecture number 30th. And in this lecture, we will continue from where we ended up. So, we reached to a point where we have seen that when the current is passing through the electromagnet, the magnetic field is produced. And we have seen that magnetic field is produced if the current is in the upward direction. The magnetic field is like anti-clockwise, and if the current is in the downward direction, the magnetic field is clockwise, and that can be given by Fleming right hand rule. Right now, same thing, same wire having a current and everything. Now we will place it within the permanent magnet like this. You can see yourself. Here are permanent magnets. The direction of the magnetic field is from north to south, right? From left to right. And this is a wire where the current direction is in upward direction, right? So what will happen when these two magnetic field technically interact with each other, right? One field is due to the current flowing in the upward direction, and one is the permanent magnetic field, which is going from left to right. Now, important point is both the magnetic fields are at 90 degree to each other technically. So what will be the situation here? So if a wire carrying a current is placed in a magnetic field with lines of forces at right angle, then it will experience a force. So basically, there will be a force experienced by that wire, and due to that force, this wire start rotating. That's what the point is. And that force on the wire is increased. Now, how do we increase that? If we increase the current, or either you have a strong magnet, or you can see you can increase the length of a wire in the field. So there are three things you can increase the force, because as the force increases, the rotation will increase. That's what we see in a few minutes. Now, what exactly? How can we predict the direction of the force? Because direction of the force can be given by certain rule, and that is what we call Fleming left-hand rule, right? Now, when you say Fleming left-hand rule, now check this out. This is very important because this is the basis of the working of a motor, so you need to understand that. Now, if you check this out, that finger is the direction of the permanent magnetic field from left to right, right? Now, this is the direction of the current, which is in the downward direction. And this thumbs will show you the direction of the force. Remember that these all three fingers are at 90 degree to each other. We can't show it in 3 dimension, but remember that these all are having an angle of 90 degrees. So if the current goes in the downward direction, and now from north to south, if you have a permanent magnetic field, then this thumb shows you the direction of the what do you say about that? The direction of the magnetic field. In this case, you can see that the direction of a current is not in the downward direction, but in the upward direction. So this thumb goes downward. You can just put your finger into the direction of north like that. I mean, straight line, a straight finger in this direction, and the current direction in the upward direction. So you will turn your left hand in the upward direction. So your thumb will automatically come in the downward direction. So that's how you find out which way this force will be actually applied. So it will start rotating, or at least go up and down like that. Okay. So this is the way to find out the, uh, you can say, the direction in which this wire will be going up and down, right? Now, this is the direction. Remember that all the lines which you can see, either a forefinger or second finger or the thumb, they are at 90 degree to each other. Now, some device use that fact that there is a force on a current carrying conductor in a magnetic field. Now, loudspeaker is not a part of our syllabus. This is our part, simple motor. Now, what does motor do? That's important. Motor converts electric energy into mechanical energy. That is a device that is used electrical energy into mechanical energy, right? So that is what the motor do. Now, how does it work actually? Now, what will be the difference? We will talk about this in a few minutes, and I'll show you the presentation as this. Now, instead of a wire, right, you can see yourself, instead of a wire, we are placing an iron core. On that, there is a wire wounded. Now, why there is an iron core? So that this technically will move this core. Core means a full iron piece. We called it iron core, right? Now, once the iron core is being placed here, what will happen? For that, I have a small presentation showing to you. And that presentation is very, very important in that. Check it out. Now, if you check this out, what will happen? You can see this is a sort of a wire, right? Which is placed within permanent magnetic field. Now, instead of that, if you just place that iron armature, we called it armature, remember that. So when you place this iron armature, you got this as a north pole, and this is the current. This is called a commutator segment. So basically now, first of all, remember that we are talking about a motor now. So motor got how many things we have it? We got an armature. This is iron piece. Then this is a power source. This is permanent magnet, and there is a commutator segment. Commutator segment is this one, along with these are the brushes. This is, we call it commutator segment, and this is what the whole system is. Now, how does it work, right? When the current is passed from, because we are considering the conventional current, so as soon as the positive current is going from here and here, what will happen? Check it out. Now there are two direction of the currents, right? One is in the left hand side, the current is going this direction, and in this the current goes in the downward direction. So it means there will be two forces produced in that, and that is how the armature will rotate. Now, how do you actually propose or tells that this armature goes or rotate in the uh, anti-clock, or sorry, clockwise direction? That will be given by Fleming left-hand rule, as I just told you. Now, how does it happen, and how do you actually apply that Fleming left-hand rule here? Check it out. Now, this is very interesting. Here, the direction of current in upward direction, and the north is on that side, south is on this side. So you just put your finger here, right, in the direction of from north to south, and thumb is in upward direction. Not thumb means the current is in downward direction, showing it. So you just move it this way. So what will happen? You can check this out. So as soon as you apply the, yeah, this is the direction of the current here. And here you can see that the direction will be in upward direction. Now check it out. How? The north is A, the thumb, I mean the current direction technically in the downward direction. So if you take this one, for example, the direction of current is if downward, so direction is upward. So if the north pole is there and south pole is there, if you apply that rule, you will see the direction will be, direction of the force is in upward direction. When the current comes here, the current comes in the downward direction. And if you apply here, actually, what you will see that the direction of current is, I mean, the direction of the force or applied force is in downward direction as well. So what will happen as these two forces are applied, one in the upward on that side and one in the downward like this, you will see that this armature will rotate in clockwise direction. So these two forces are of equal magnitude, right? And because these two forces are equal magnitude and technically speaking, they try to rotate an object. So we call that a couple force, right? Now this couple force is rotating an armature in the clockwise direction. Now, while it's rotating, once it reaches to this point, now remember one more thing. This is very, very important, which actually I wanted to. Now, what exactly the thing is, once you noticed one thing that when the current goes this way and that way, they only showed you that it will rotate. What happened when the current goes in that particular side and here? Remember that the current direction of the movement of the current and the direction of the magnetic field should be at 90 degrees. So only these two sides, once the current passes through, will actually contribute the movement, while when the current direction, or you can say the magnetic field, permanent magnetic field direction are same, then technically speaking, it will not contribute into any sort of torque. So once the current passes through that and that, these are the two things where the current is actually, I mean, there is a force applied. So you can see yourself here that here the force is applied in the upward direction, here in the downward direction. Now these two forces are same in magnitude, but opposite in direction, and they are perpendicularly away from each other. This is the definition of a couple force. So couple force produces, and this couple force will rotate this armature. So this armature is start rotating like that in a clockwise direction, just like that, like it is moving like this. Now, one by one, what are the major components for that? Firstly, you have that permanent magnet, then you have this armature core, then you have that battery, and this one is the commutator segment. We call this commutator, and these are your brushes. So commutator segment along with the brushes. Now each one has a separate function, right? This is called brushes, right? Uh, Now when you say armature segment, this one, when you say armature segment is that this is permanent magnet, battery, and this one commutator segment, right? Now commutator segment is consist of two things. These circles are called as split ring, and these brushes are called as just carbon brushes. So technically speaking, how many major components you have it? One is your armature assembly or armature. Armature means a rectangular box, along with that the wounded wire. So armature segment. Then you have a permanent magnet. Then you have a battery. And last one is the commutator segment. That commutator. Now, in commutator segment, there are two major things: carbon brushes and split ring. Now, everybody has a small function in it. Let's further, we will discuss it as it's, let's see what happened. So your armature start rotating, right? Due to this movement, which is produced by the uh, couple forces. Now, what happened? Once it rotates, due to, that permanent, I mean, this Fleming left-hand rule, it starts rotating, as I just said it, due to a couple force and all. Now, what actually happens? That's what I wanted to show you. Now it's rotating, right? The point is, while rotating, right? Let's keep on rotating. Let me see if it just, okay, here. Once it reaches to this point, that point. Now, that side is actually become parallel to the direction of the movement of the magnetic field lines. The question is now what will happen? How do this armature will further rotate? So at this point, remember that because it was rotating, and this point, the momentum of that armature is very high. So that momentum or that inertia of this uh, armature core is so high, so it will pushes that armature, and so it keeps on rotating and it moves from that position. Now, once it moves, right? Now you check this out. This side and this side. Once it rotates, now question arises, check it out. It's rotating. Now, one by one, we do understand function of each thing. These permanent magnetic field producing a permanent magnetism. Okay. Armature core, or you can say wounded wire along a iron core, is just produce, you're just passing the current from the power supply, and it definitely produce a magnetic field within the wire, right? Power supply is definitely giving you the current into that. And then you have a commutator segment. That commutator segment, that brush is just giving you a connection. It's just to give you a secure and power saving connection between the main supply and the armature. What is a function of this split ring? That's what I wanted to show you. Now, this side is connected to that side, right? And that armature, I mean, split ring side is connected to the other side of the armature. Now, question arises when it rotates, right? Check it out. Now, at this point, once the side which was here, let's suppose that was a side, let's assume that this is your AB and this is your CD, right? Now, question is while rotation, now check this out. Once that AB goes to that side and CD comes to that side, now what will happen? The point is the current direction is same. So if the direction of the current remains the same, technically speaking, the armature should go in one direction and then it will turn into another direction. The problem started here. So what will happen? Because as soon as the direction of the armature changes, there should be the change in the direction of the current as well. And that thing will be performed by that split ring. So what is the job of a split ring? The job of a split ring is to make sure that the armature will rotate in one direction. And that's how, and what is the procedure of doing that? It just changes the direction of the current as the direction, as the armature side are going to be interchanged from one side to another side. So technically, armature split ring job is to just make sure that there will be a uniform direction of the armature in one direction, uniform direction in one direction, you can say, or you can say there will be, it makes shows that armature rotate in one direction by just switching the current. So now one by one, what are the functions? What are the main components? The main component is a permanent magnet, which is definitely produce a strong magnetic field. Secondly, you have a armature assembly, which is actually comprises of armature core and the wire wounded. This is the armature core where the current once passes through, it produces a magnetic field within the armature, right? This is the power supply. Power supply is just a power source that produces or that actually produces a current, right? And then you got that armature core, which is comprises of brushes, carbon brushes, and split ring. Now, what is the job of carbon brush? It's just giving you a connection. That's it, right? So it just gives you a secure connection between the power supply and the armature assembly. So if somebody will ask you, what is the job of carbon brushes? So carbon brushes just provide the proper and secure and safe connection between assembly, armature assembly, and the power supply. Then you have that device, and I already told you that device make sure that armature core will be rotating in one direction by simply switching on the current when it is required. Okay, so this is the function of a motor. And in motor, what actually happens, you can see yourself, the electric energy converts into mechanical energy. So there was a small thing, a small demo, or you can say small details about the thing we already done. So Fleming left-hand rule is the same thing which we have already talked about, which is using a thumb, a straight finger, and the second finger to find out the current, I mean, the direction of the force applied on an armature, right? So I believe you understand that. Now, there are a few things which are very, very important once again. So coil is made of insulated copper wire and is free to rotate between the poles of a magnet. The commutator split ring is fixed to the coil and is in contact with the brushes from the DC supply. Now, this is your commutator, as I just talked about it. What happened? These are the position they are showing you. This goes this way, this way. If there was no change to the force, the coil would come to rest in the vertical position here. But what will happen? but the coil has a momentum, so it overshoots the vertical position, and commutator change the direction of a current through it, so force changes the direction. And that is how it makes sure that the device will continue its motion. I mean, the armature coil. Now, how to increase the turning effect of a coil? Can be increased by increasing the current using a strong magnet, or you can increase the number of turns on a coil, or you can increase the area of a coil. All right. So this is the small description related to the DC motors. Now, the next small topic, which is our next topic, will be electromagnetic induction, which are the basis of AC generator, which hopefully we will discuss in the next class. So that next class will be related to the basis of AC generator. How we will see that how the electricity will be produced. First, we see the basis of that, and then we come to uh, the basic theme of AC generator and how does it work. So hope to see you in the next class, which is our 31st. Thank you very much for watching. Bye.